Record. Great. Well, good afternoon. My name is Dave Riedmiller. I am the director of the Climate Center at the Gulf of Maine Research Institute. For those that don't know, at GMRI, we pioneer collaborative solutions to global ocean challenges. And without a doubt, the foremost global ocean challenge of our time, of course, is climate change. Before introducing this series and today's speaker, I'd like to turn it over to Skylar, who I believe will introduce Gateway Community Services and its Color of Climate program. So Skylar?
Yes, thank you. Hi everyone, I'm Skylar from Gateway Community Services Maine. So Gateway is a nonprofit organization created to support the well-being of immigrants and refugees new to the Greater Berlin and Lewiston areas. So we offer support services for them and members of the community. And I specifically work with the Color of Climate program, which is a program that centers around youth, specifically BIPOC youth, Black, Indigenous, and people of color, and their voices and experiences, specifically around climate change and environmental justice. We partnered with GMRI and to have this speaker series for the youth so they can ask questions and see leaders in the climate field. Happy to be here.
Great, thanks so much, Skylar. So part of GMRI's climate-focused work is really to support a network of regional peer communities of teachers, informal educators, and librarians as they work with youth to investigate locally compelling and relevant impacts of climate change. That work, as Skylar just kind of articulated, was a natural fit with Gateway's Color of Climate Coalition. And while that may sound simple enough, early conversations with Gateway about the youth they serve revealed kind of a much more complex perspective on climate change. And these youth from families of origin across the globe naturally have a much more global perspective on what kinds of climate impacts might be considered local. And so listening to the youth and the colleagues at Gateway, we came to see that questions about how climate change interacts with human migration globally is front and center for them. And thus was born the idea of a speaker series focused on this issue to allow educators and youth from across the state to explore the topic further. In this, I guess in the inaugural presentation back in March, we heard from Dr. A.R. Siders and Erica Bowen, who addressed many of the myths of managed retreat. A key theme emerging from our discussions at that point was the complexity of the issue and how it's yet one more stressor on communities that already are the hardest hit when it comes to climate impacts. The climate and social justice lens that needs to be applied to ensure equitable outcomes has come into stark focus as a result of that conversation. And last month, in the second installment of the series, we learned from Nadia Sitaram at Florida International University about some of the varying risks and vulnerabilities to sea level rise over time and how that may lead to different migration outcomes for coastal communities, especially where climate adaptation and policy interventions are inadequate. And today, we're fortunate to welcome Dr. Alex de Sherbinin, who will help us zoom out a bit and look at climate migration beyond the United States. Dr. de Sherbinin is the Associate Director for Science Applications and a Senior Research Scientist at the Center for International Earth Science Information Network, an environmental data and analysis center within the Climate School at Columbia University. Dr. de Sherbinin is an expert on climate-related mobility, which includes voluntary to forced migration, displacement, resettlement, and seasonal movements. He directs the Climate School's Climate Mobility Network and leads the modeling team for the World Bank's Groundswell series of reports. He holds a master's degree in geography from Syracuse University and a PhD in geo-information science from ITC-University in Twente in the Netherlands. So before I turn it over to Alex, I just want to cover some logistics. The first is that we'll be having a general Q&A period for all attendees afterwards, and then we'll likely excuse those non-youth among us to allow for a more focused conversation with our speaker. And I'll just invite everybody to kind of feel free to use the chat window throughout our time together. We'll be tracking it and bringing up questions or comments for our speakers at the end. So with that, Alex, feel free to share your screen and whenever you're ready. Thank you.
Great, thanks, Dave. And really nice to see everybody here. So I'm speaking from Palisades, New York, which is the unceded territory of the Lenape Indian tribe and Native American. And I am at CIESIN, which is a center which you'll see a lot of data and other things that we produce as I go through my presentation. I have some connections to Maine. My sister lives in Brunswick with my brother-in-law, and every year I bring a group of kids, at least pre-COVID, and this year we're resuming from New York up to a camp in Maine called Camp Good News, and had the real pleasure of interacting with some kids from the Root Cellar, which is one of the programs in Portland that works with a lot of immigrant communities. So I feel like I should be at least an honorary citizen of Maine, if nothing else. So here we go. And I'm a big fan of the state, obviously. Most recently hiking in Baxter State Park during COVID, which was a great relief from craziness of the city. I don't know if that's actually sharing properly. Seems like something weird happened. See if I can do this again. That time it worked. All right. So thanks for joining us, and I'll try to go through some of the intro material fairly quickly so that we can get to other more interesting facts. So I think, I was kind of asked Sarah, well, is this too general, but maybe a little bit of background on climate change. Most of you are aware that it's the greenhouse gases that are trapping shortwave radiation from the sun and keeping it from kind of bouncing back out. It can, like a greenhouse in the real world, it creates a warmer temperature. And so that's the main mechanism that greenhouse gases serve, and they're actually a good thing when and like all good things in moderation, but when you get too many of them, that's the problem. So what we're seeing, of course, is evidence from around the world that there's increases in certain things that show that the world is warming, such as sea surface temperature, temperature over oceans, air temperature near the surface, and sea level. And there's also things such as ice cover and sea ice. So these are things that are all signs of a warming world. And these are, this is sort of a quick snapshot of the kind of warming that we've seen over the last 50 years. And I would say that the main take home here is that global warming and climate change is not occurring evenly across the planet in every place identically. So we are seeing very different patterns of impacts in different regions. Of course, we know that the concentrations of CO2 are increasing in the atmosphere very dramatically from historical levels. We somewhere in the 1800s discovered rock oil in Pennsylvania, and since that time we've been burning it at ever expanding rates. And so unless we cut down on our propensity to burn that rock oil, otherwise known as fossil fuels, we're going to have a real problem on our hands. So these are some of the projections. Actually, these are not the most recent. I apologize, I should have brought in the AR6 or the IPCC recent assessment report. But the main message here is that even if we reach the 1.5 degree Paris targets, the disruptions to our systems will be very substantial. So a kind of best case scenario is this blue line of called RCP 2.6, or representative concentration pathway 2.6. And what we really want is this kind of runaway climate change of RCP 8.5. Now, fortunately, a lot of the scientists are now saying 8.5 is pretty much a worst case, far off, seemingly impossible, nearly like very low probability scenario. But there's still always some risk that through tipping points and other things that we actually reach that level of warming by the end of the century. And of course, human civilization does not drop off the cliff at 2100. We hope that it will continue for hundreds of years. So we need to be thinking about what goes on beyond this line to the right. So one of the main messages of my talk today is that the envelope for the activities that sustain human civilization, all the systems, agroecosystems, our industrial systems, our hydrological systems, all those systems are changing rapidly, and yet our current human, population distribution is adapted to one particular kind of climate niche that we've been used to for the last several millennia. So as temperatures increase, we'll also see more extremes, and this is part of the story that I'll be talking about today, is not just the long-term impacts of climate change, but these tail-end extremes where you have extreme hot weather, more of that, and maybe weather we've never seen before. Recently, I heard that the subcontinent of India has received, had temperatures that exceeded any recent, any kind of historic levels in the month of March. And they're already experiencing the kind of hot weather they experienced just prior to the monsoon here in April. And the monsoon doesn't usually take hold in late May, early June. So these unprecedented extremes are occurring more and more. But you could take this same distribution and look at extreme rainfall, in fact, any number of things. This is for the US alone, the ratio of extreme highs to extreme lows compared to like the past century or so of climate records. And what you're seeing is that more and more that the ratio of extreme highs to lows is actually growing as time goes on. This map just shows the percentage of or change in the percentage of rainfall that occurs in the 1% heaviest events. So these are these really extreme downpours. This morning, actually, here in New York, we experienced thunder and lightning and some really intense downpours. And what you're seeing is those percentages are increasing, particularly in the Northeast. So 40% increase over time from 1958 to 2016 in the number of events, in the number of events that exceed that 1% heaviest of events. Cyclones are also increasing. I'm going to remove some things that are hiding my view here. And so cyclones are increasing heavily, and what we're seeing is globally a slight increase in patterns of the most extreme events, which is the lower line here. But in the US, in particular North Atlantic and including Central America and Mexico, what you're seeing is basically fairly substantial increase in above normal energy indices for the cyclones that are occurring. And the cyclones that we're seeing are both catastrophic in two different ways. One way is just the extensive wind damage that occurs from these very supercharged events. But you're also seeing an increasing number of events such as Harvey and Dorian, where a system just sits over the land area over a long period and dumps levels of rain that have never been experienced before in both the Bahamas and in Houston in the case of Harvey. So these events are kind of increasing in frequency and are causing a lot of damage. And you don't have to go too far in the media to see reports on these events. Forest fires are also increasing in the extent of areas burned. This is just the Northwest US. And of course, last year we had this heat bubble over the Northwest where unprecedented hot temperatures were lingering for a matter of weeks and causing a lot of discomfort. So these are all the warning signs in a way of a global, crisis, a climate crisis as it's often referred to. And so they also raise some substantial issues about questions of habitability. So I talked earlier about this kind of climate niche in which humans live. Climate change will affect things like basic human survival, livelihood security, this capacity of societies to manage environmental risks. They kind of undermine it can undermine fundamental governance. It's often called a risk multiplier, something that kind of adds risk to issues of human governance and issues of national stability in many countries. So we do a lot of modeling, and I'm going to touch on that later. The top-down modeling has its limitations. In this article for Science Magazine, we kind of outline some of these issues in terms of what the benefits are of some of this top-down modeling, but also the strong sense that there's very strong limitations. So when you see these maps of kind of changes that will occur over large areas, they really need to be complemented by research that is social science informed. It goes down to the ground level, talks to people on the ground, figures out what the core adaptive capacity is in different regions, in different parts of the world, local governance structures for dealing and making decisions related to, making decisions related to adaptation, and then social feedback mechanisms and things like that. So we can come back and discuss that later. So in terms of what we know about migration, basically this kind of Rabenstein's law from 1885 still does a good job. So many, a century and more later, almost 150 years later, of describing kind of key factors. And the way it's often been described is that there are these mix of factors at origin and destination that cause people to either be attracted to or want to stay in place. We call these kind of mooring factors, things that cause people to really like invest in their local communities and stay where they are because of like the social cohesion and things that they value, the local landscape of the locality. But there's also these attractive factors at destination that can lead some people to say, well, as situations deteriorate at the origin, or if they just get dissatisfied with where they're at in their origin area, they may decide to go to some new area. And in between, there are these intervening obstacles. Some basic tenets that we can say, or stylized facts, are that that migration tends to increase over time, so that over a period of time, you'll see more and more people migrating. It's selective, meaning that some people are more likely to migrate than others. There's a higher proclivity among younger males, in particular, in many parts of the world, compared to older demographics or women. And economic motives tend to dominate in most of the world, but increasingly environmental factors can interface with those economic factors. And I'm not going to cover this lower bullet too much, but the way of thinking about some of these issues is that you have these environmental hazards that occur on a either regular basis or very rare, and they interact with social vulnerability and people's individual characteristics, poverty status, education status, things like that. This creates risk, and this could lead to mobility, but there are a number of factors that intervene, such as governmental responses, like if you have a disaster management agency in your country, like FEMA, can you issue insurance and other things that allow people to recover from disasters or from climate events? What is past experience with migration as a risk reduction strategy? Have people often gone to migration as an option in terms of addressing some of the things that they need in terms of livelihoods and in terms of their way of making a living? Availability of other types of responses, and finally, one big factor is perceptions, and it's not just perceptions and experiences of environmental hardship, but also sometimes in anticipation that things may not get better where they are. And what we're hearing more and more from many field studies is that narratives that go, things are not going to get better here, that in fact it's going to be harder to grow your crops or whatever, are pushing a lot of people to make the decision to leave rural areas and move to cities, for instance. And these will, of course, feed back to social vulnerability over time. So as people move out of an area, social vulnerability is affected as well. This is a very complicated diagram, but the simple take-home message is that environmental factors rarely operate on their own. When people make decisions about migration, they're more influenced by particularly economic factors, but also demographic, political factors, and social factors, like whether you have kin in the destination area, or if you have obligations at home and you need to stay at home because your grandmother or some elderly relative needs tending to. We're seeing that today in the case of the Ukrainian crisis. They're interviewing people on the front lines, and many people are deciding to stay despite the risks, the inherent risk, because they have elderly elderly family members who they need to take care of, and they can't leave those people alone, and traveling with them would be very difficult. And once you factor in sort of these elements, environmental issues can either act independently, or they can affect each of these through sort of different causal pathways, and ultimately lead to decisions to stay or to go. So this is kind of what that diagram seeks to describe. So, you know, there's a lot of media attention to this issue, and people are, it's now become, you know, part of a national security debate. You might have heard some news reports about what goes on in the southern border and concern. And I think part of my role I see is kind of saying, well, yeah, things may pick up in terms of international migration, but maybe that's not the whole story. And climate is not really a primary driver. These are very complex, there are very complex causal mechanisms in many parts of the world. And let's not securitize the issue of migration. People are leaving countries because situations are becoming dire in many cases. And so how can we address those situations and improve lives for people who want to stay? And how can we facilitate migration where possible, and make it less onerous for people to come to countries like the US to you know, as part of a larger adaptation portfolio. So the research that we base our understanding of climate mobility on is kind of covers a range of times and epochs and periods. So we can go back to prehistory and look at massive migration patterns that have occurred, like the collapse of the Maya or the Western Roman Empire, in a period called the Great Migration Period. We can go back much more recently to the 1930s, into sort of newspaper and other accounts, and even other recorded history from events that occurred, such as the Dust Bowl that drove a lot of people from the Midwest to California, which is partly a climate crisis and partly an issue of land management and kind of a lot of investment in agriculture in marginal areas where the land was not really suitable for that kind of intensive agriculture. So when the drought finally did strike, the soil just started blowing in the air. And in one point of the Dust Bowl, they were debating what to do about it on Capitol Hill, and there was dust blowing from Oklahoma all the way to Capitol Hill in Washington, D.C., because that's how extensive the loss of soil cover was in that area. More recently, what we've seen a lot of is these very careful statistical analyses that take demographic data from surveys or censuses and couple them with precipitation and temperature data from climate models and from, well, mostly historical climate data, and look at the relationship between climate mobility trends and climate dynamics to see if temperature or precipitation or extremes in both of those things may be able to explain some of the movements that we see. And more recently, also, we've seen a lot of work on displacement and looking at how extreme events might cause people to leave. So this is an example of using, for instance, tree ring data to measure changes in the climate over time, and you can tell whether a year was particularly dry or wet based on the width of that tree ring. There's textual analysis that occurs in some place, archaeological analysis, and all these things are used to reconstruct historical climates. And then if we know that a particular civilization collapsed, or if we know that a given migration occurred, we may be able to tie that migration to events that occurred in that, climate events that occurred in that area. So I mentioned there's interest also in these historical analogs where we do have much better data on what happened, how many people moved during the Dust Bowl era, or how many people moved to cities during both the drought in Brazil in the 1950s and then a subsequent drought in the West African region called the Sahel in the 1970s and 80s, and we're able to kind of tie those to some of the climate events and impacts that occurred at those times. These are some examples of historical analysis. This is specific to Mexico, and they were looking at how the number of drought months might lead to rural-urban migration, and the number of extreme heat months. In the kind of this curve diagram shows that a sort of normal number of heat months might not lead to so much rural-urban migration, but if it goes, if there's a lower level of heat months, then the probability of migrating goes up. And if there's a high levels of heat months, it goes up. And the drought months just tend to go up with the number of drought months, the migration probability tends to go up. So this is one example of findings from a very detailed statistical study that looked at a combination of demographic data and climate data. This work looks at internal displacement and kind of just essentially assesses the number of people displaced globally. It's a report that comes out every 2 or 3 years, and it's basically a measure of how weather-related events have impacted displacement. And you can see some years just massive displacement. Often if there's an event in the blue bars, by the way, are weather related, and the others represent things like earthquakes and volcanoes and other geophysical hazards. And so some years, maybe you have a big weather related event such as a flood or something that occurs in a place like China where there's very large populations and the numbers just go way up. And so that sort of gives a sense of some of the another stream of data that people look at. And this is an example of some work that colleagues of mine did in Syria. Most of you may be aware that Syria experienced a civil war in the early 2010s. So just the last decade and the early part of the last decade. And a question was whether there were climate precursors to that conflict. And indeed, there was a massive drought that occurred in Syria during that time, leading up in the period just leading up to the massive conflict. And their hypothesis was that basically the drought led farmers to give up on farming, or actually what happened more specifically was the drought led them to seek government assistance. The government assistance was not forthcoming. That prompted more and more dissatisfaction with the Assad regime, and then migrants from some of these farm areas ended up in urban areas, and that helped fuel the crisis. Now there's others who contend that that's not really a major or significant, the drought was not a major or significant factor. So these things are a matter of debate, and it's not an open and shut case. Often these relationships are very difficult to tease out because we're talking about complex systems. So is the threat of climate refugees, like I showed on that first slide, just media fear mongering? Are ultranationalists grabbing a hold of this and saying it's going to get worse and we better close the borders because this is what's going to happen? Well, a kind of more serious scientific approach to this, in this particular report, which we contributed to at CIESIN, called the UK Foresight Report on Migration and Global Environmental Change. It's about a decade old, so you might consider it somewhat dated, but it's still one of the benchmark investments in research in this area. And it basically did find that, environmental factors have contributed to population movements in the past and are likely to do so in the future. That, migration is undertaken to ensure income, but under adverse environmental conditions such as drought or extreme heat, you can imagine that people are actually may need to migrate in order to, get new work or find new opportunities. Rural-urban migration has increased in some countries because of environmental change, according to their findings. Environmental change will likely influence future displacement of migration, which I'll get to in a moment. And one important finding was that there's actually a real risk that not of migration, but that people become more and more impoverished in place. And so when we talk about low-income countries, more and more people may not be able to move because their household assets, the animals they use to cultivate or get food or milk, the tools they use or other things they may have sold off in order to be able to sustain themselves during a time of drought, and that makes it harder for them to recover after the next drought. Most migration is going to occur internally, and that's a pretty consistent finding no matter what review of the literature you find, that it's internal migration is probably the biggest proportion of all migration, and that refugee flows will be largely between countries in the low incomes regions of the world, south to south. Temperature and precipitation can both help explain migration patterns, but their effects vary. In some cases, increased temperature leads to more migration out, and in some cases it leads to less migration. And that suggests that actually it's the economic drivers and policy and culture that mediate these environmental impacts that are really the biggest causal factor. And then some planned relocation or resettlement is already occurring, and we should expect more in the future. And this is something that I've written about with other colleagues to talk about, like anticipating the need to plan for future settlement in the future. So how many people will move and by when? And this has been this is getting into like future scenarios and looking ahead. This has been a matter of some debate, and there have been a lot of what we call back of the envelope estimates of numbers of people who have either will be affected in the future or may already have been displaced by climate related impacts. And frankly, it's sometimes hard to know how these numbers were developed and what methodology people use. So we worked with the World Bank on this report series called Groundswell, which David was kind enough to mention. And basically, the Groundswell approach was looking at ecosystem dependent livelihoods, meaning people who live off the land in one way or another, particularly rain-fed agriculturalists, but also pastoralists and others, and who are vulnerable to climate variability and change. And so the question, is, can we build robust systems that allow those people to stay in place, or will changes occur that might tip the balance in favor of migration? An example of that might be a very specific case. So this looks complicated, but basically the x-axis measures the intensity. So imagine a drought, and if the drought is really long-term and very catastrophic, like the massive drought that they had back in the around 2015 or so in California, then that's kind of considered catastrophic in terms of the intensity. And then if you start getting increasing frequency of events, so we can imagine a nominal drought, a relatively benign drought occurring almost every 5 years. But if you start getting really high and intense droughts every 5 years, then you're in this area of intolerable risk. These are risks that cannot be easily adapted to. And so the example here is basically the decline in rice yields as a result of temperature changes. And the question then becomes, at what point will subsistence farmers no longer be able to adapt in location where they are and be forced to move to urban areas or cross borders. And this is part of what motivated some of our work with the groundswell. Now, I won't go into the methods we used, if that's really a longer presentation, but the take-home message that you can take from these sort of charts and graphs is we modeled every individual country shown in these maps here, and then we pieced together regional pictures of what's going to potentially happen by the year 2050. And what you see here is basically three different scenarios: a pessimistic scenario with high emissions and bad development outcomes, a more inclusive development scenario that still has high emissions, but where society does a better job of handling those emissions and creates a more kind of resilient future. And the last is a more climate-friendly world where the emissions are greatly reduced, but you still have a somewhat bad development outcome. And what you see is basically the pessimistic or high emission scenario really being the highest in terms of the number of potential climate migrants by 2050, up to 216 million. So that's the high end of this uncertainty bar, or this we'll call whisker diagram here. But it's worth noting that if you had a more climate-friendly future, that it could be as low as 48 million people. And that the largest numbers proportionally of the population are in sub-Saharan Africa. So sub-Saharan Africa currently does not have the world's largest population. That's actually in East Asia and the Pacific. But the number of climate migrants projected is much higher in that region owing to high climate sensitivity. We used actual impacts on water availability and crop production, as well as sea level rise to inform these projections. So we were looking not at just changes in rainfall and temperature, but we're looking at actual impacts in the systems and sectors that are important to farmers and to pastoralists and others in looking at this issue. I was told that there's some potential participants in the group today who are from different parts of the world. So China was mentioned. What you see here is basically these hotspots represent red areas, even though the colors look a little different in both of these maps. The red areas are typically areas where all three scenarios agree that there will be high levels of in-migration projected in the future. And the blue areas represent areas that are likely to see out-migration in the future. And for China, that's largely the sort of southern portion of China and parts of the southeast. The regions that are already heavily urbanized in the northeast would see a lot of increases in mobility towards them. In Africa, the picture is, takes a little bit more explaining, but basically coastal areas in general see a lot of decreases well, not decreases in population, but increases in climate out migration or people moving out. And the red areas are areas that would see increases in climate mobility in. One of the things that we're seeing is some of the climate models project a lot of wetting or increasing precipitation in the eastern Sahel. So that's why, even though this northern Nigeria region here is one that's characterized by a lot of conflict, you're seeing increased mobility into it. The area of Lake Victoria is also an area that we see increasing mobility in. So some of the countries that I was told people on this call might actually be interested in include Democratic Republic of Congo and Eastern Congo. Shows a lot of in-migration. This is a highland area in the east of the country. The highland areas of parts of South Africa see increasing migration in, and kind of low-lying and coastal areas see migration out. Kenya sees some movement towards Lake Victoria, and then Somalia is so thinly populated that not much shows up there. This is more recent work that we've done as part of something called the Africa Climate Mobility Initiative. And what we did was we essentially looked at hotspots. These are taking, in essence, the kind of same areas as described here, but actually mapping the population change within those areas. And They're not exactly the same because the modeling approach we took was a little different here, and we had different inputs. But what you see is areas of northern Nigeria and southern Niger showing up as in-migration hotspots, as we saw in the last work that I showed. Northern Ethiopia showing up as an in-migration hotspot. The same in-migration in eastern Congo and parts of the Lake Victoria Basin, and then some change in Malawi, including a lot of out-migration from southern Malawi. So questions closer to home, what might happen? It sounds like you already had CITERs and Nivetha coming and talking to your group, so you're familiar with their work. I will then cover this fairly briefly, but this is results of some a presentation I gave to the Environmental Business Council of New England last summer, and so it's relatively fresh work. And so some things that may be occurring in other parts of the US may affect migration to the Northeast and to New England, in particular Maine. That includes flooding and sea level rise in the coastal zone. So the red areas of Florida, but also the Gulf, show share of homes with high risk of flood. And in Florida, apparently 10% of homes are in that category. Wildfires are driving some people to seek more calm and less fire-prone regions. So we've seen some media reports of that. I will say that a lot of this evidence still is very anecdotal. So there's not a lot of concrete evidence to show, or at least statistical, hard statistics to show that there are a lot of people moving from these areas and instead choosing places like New England. In fact, I haven't done an extensive analysis of the census, but my guess is that these regions still remain fairly attractive for people because people want to live well out in some nice rural wildland area. And of course, those are areas that tend to be very fire prone. And then drought severity is also causing some people to sort of say that the situation is getting worse. And you also have extreme heat impacts, particularly in the southern portions and the central portions of the US. So these are some projections that do not take into account climate change that a colleague did and that we distribute through our NASA data center here at CIESIN. And it shows southern Maine largely increasing, not too big a surprise here, largely owing to past trends in urbanization and attractiveness and jobs, and largely projected declines, fairly small or modest declines, as you look at change in population by 2050, or between the period 2020 to 2050, small declines in parts of northern Maine. And this is, sorry, I'm now looking at projected change under a different scenario. So these are two different scenarios. Pardon me, I forgot there's animation here. So this is a scenario called SSP3. And this is actually a scenario that drastically curtails migration into the United States. So compared to the last scenario of SSP1 that you saw, basically a lot of New England becomes essentially loses a lot of population, and only some areas of New England see some gains. And so that would be the kind of build the wall scenario for the US. And this is another scenario called SSP5. SSP5 is a scenario where you have very extensive fossil fueled growth and development in the world. And this is kind of a bad world for the climate, but a good world for the economy. And you see a lot of dense growth in New England. But those are just taking into account what might happen from a kind of purely socio-demographic and economic perspective. What we need to start thinking about in the US, and a lot of people are beginning to think about, is how people might move into places in New England where there may be increased climate risk. So people may leave the hot areas of the South, but come up to the Northeast and then find that they actually are in areas with ever increasing numbers of days that are above 90 degrees. So you can see, it's interesting when you look at kind of the Hudson Valley and the Connecticut Valley and then the area around Boston is just how the lowland areas in these kind of corridors of heat go up. I grew up in Western Mass and Amherst, and the summers could be pretty hot and humid, but they're going to get more hot and more humid. And of course, now I live in New York, so I'm really out of the frying pan into the fire down here in the city. And then you can look at things like flood risk and vulnerability. This is a vulnerability index that we also distribute through our NASA data center. And one of the things I found kind of interesting in looking at the patterns was how a lot of the former industrial cities in New England really were along rivers. You know, that's where the mill towns are. And so the mill towns then have, to this day, remain fairly, well, at one time they were very economically advanced and probably the place you wanted to be, but now they are largely losing a lot of their economic vitality. Towns like Lewiston, Auburn, and other towns in Maine may fit in those categories, but at least Lewiston, Auburn have, colleges and other facilities, major hospitals and things, whereas the farther north you get, probably the poorer it gets. And so river flooding will be, something that you're going to see more of due to those extreme rainfall events I was describing earlier. And then you can look at situations of sea level rise in the coastal zone and how that will impact certain places like Revere here, shown in this article, where, combinations of surge, storm surge and sea level rise are likely to overtop a lot of the, the coastal infrastructure and cause more and more nuisance flooding. So there are these now efforts, small and fragmentary and essentially anecdotal, as I said, but reported on by the media, of people leaving certain parts of the country, the South in this case, to come north to farm the land or to do things that they can't do or don't have as much confidence in being able to do in the future in the places that they're coming from. So I think this is an effort of a community in Mississippi to move to Vermont and essentially set up a farming community there. So to summarize, I think I've gone a little over time, but I'm going to stop here. Climate change and variability are already affecting mobility of all types, including longer-term migration, but largely, the most direct impact is really on those short-term extreme events that do tend to displace people. Often people then move back to where they came from if it's a short-term event. We're seeing people move back to those fire-scarred environments in the Northwest. People move back to New Orleans after Sandy, and people are moving back to neighborhoods in New York that were affected by, after Katrina in New Orleans and then Sandy in New York. And so people tend to move back often after those very short-term, high-impact events. But, people are beginning to question the wisdom of that over time and wonder if they might be better off somewhere in a safer, more less risk-prone environment. There's going to be, most of that movement is going to be internal, but the small fraction that isn't international will probably grow over time, owing largely to complex factors, not just climate, but really the breakdown of civil society, increasing crime, violence. A lot of the movement out of Central America now is driven by people seeking safety and security, not primarily because of the climate factors, but the climate factors can be a kind of triggering event, like the recent hurricanes Iota and Eta, which drove a lot of people to leave Honduras. People migrate for a lot of reasons, and you can read about that there. And basically, we're at a point in our, one reason people are so focused on migration is it's kind of represents the first sign that things, that societal coping capacities may be reaching their limits, and people are beginning to have the sense that they need to move on. So that's one reason I think that people are very focused on mobility. So with that, I will close, and I welcome any questions you may have. I'll leave the slides up in case there's reference to specific figures, but please unmute yourself, or Dave, I'll let you and Sarah take over.
This is great, Alex. Thank you so much. That was a wonderful, wonderful presentation and tied in quite well to the talks preceding you. So I appreciate you kind of zooming out and then zooming back in, which was quite interesting to see. Some of those plots and statistics are pretty eye-opening for sure. Let's open it up. Who's got questions, comments, reactions, feedback? Feel free to, it's a small enough group, we could probably all just, yeah, Brady, go right ahead.
Yeah, thank you, Dave, and thank you, Alex. That was very informative. I appreciate learning from you. I have a question related to movement within the U.S. and I live here in Rochester, New York, and I know several people who have moved here from other parts of the country and have cited climate change as the main reason, although I think the more dominant trend is still people leaving from Rochester and upstate New York and going where in the country. Like my best friend moved to Florida a while back, and he's like, yeah, I prefer the hurricanes over the cold winters there. That's what he told me. But I'm curious, even with that, the maps you said it looked like even by, unless it was the more extreme scenario, even by 2050, you're still seeing a bigger trend of people leaving from the Northeast and coming here. So I'm curious, in that same model, in places like Florida, where you have more than 10% of the people there at high risk from the flooding, does it predict that people there are just going to move, say, to inland to like Orlando rather than move into other states? Or I'm curious where those people from the more vulnerable areas, where it's predicted that they will be going to.
Yeah, it's a good question. So the first part was whether, most of the Northeast will see declines. Again, this is projecting the future without climate impacts, and it's based on sort of, to some degree, extrapolation of future trends or past trends to the future. Sorry. So, yeah, there's areas that are that are kind of greenish, but what you will notice is that there's no kind of like really extreme numbers here, except maybe down, along the Connecticut coast. And that varies by scenario, or actually that's Long Island, sorry, that county. It varies by scenario. I think the case of Florida, my colleague Matt Hauer, who actually developed these projections for the US and has then subsequently done research on where people actually go to from coastal counties when they decide to move. And he used tax records. So you can actually look at people from year to year, and that gives you kind of good annual updates on where people are moving from and to on an aggregate level. It's not, you can't tell, well, did John Doe move from here to there, but you can tell that in aggregate, so many thousand people moved from Miami to some other location. And he started mapping that out. And the locations, yeah, I think tend to be within state, but there are also people who move for various reasons. And again, these are not all climate people moving for climate reasons. There are people moving for all kinds of reasons, but they sometimes move to the Midwest or other urban areas. Generally speaking, what we've seen is, over time in the US is increasing urbanization. So some of this is just a natural process of, over time, people moving out of rural areas. What I don't think, Matt could have anticipated when he developed these scenarios was how COVID has now influenced a lot of people to move into areas that were previously rural, that are rural, and that where these urban refugees who said, well, I had enough of that. I'm ready to now live somewhere where there's plenty of outdoor space. And so, that's going to influence to some degree where these patterns in the future. So some people are looking at COVID as a kind of dress rehearsal for climate change.
Thank you.
Yeah,
Sure.
Brady, great question. Great question. And I'll just note that I am a Rochester, New York native. So great to see you here, and much loved upstate, indeed. Great. What else? Other questions, comments, reactions? I've got Alex. Let me ask you one. In one of your slides where you showed sort of the country by country breakdown of, or kind of the regional breakdown the different projections. One area that was not modeled was the Middle East. And I'm just wondering if you could touch on that, either the reasons for that or kind of the commentary around it, because I know there's been some questions. Yeah, this one here, the literal hospitability of life, say, in the Middle East.
Yeah, habitability issues are huge there, and extreme heat in parts of the Gulf is, it's reaching levels where physically you cannot actually stay outside. So, we're talking about basic human survival. If you're not in shelter and in air conditioning or otherwise in a fairly cool environment, you can't really perspire enough to keep alive. And so that region was not modeled, though, not because of that, but because for one, large parts of the Arabian Peninsula are occupied by high-income countries that were of little interest to, Saudi Arabia and United Arab Emirates and Oman were not of interest to the bank because they're not World Bank client countries. But also, we basically warned them that the data for Syria and Iraq would be so skewed. The baseline data had been, we needed certain data to use to calibrate our model. And the historic data that we needed for 1990, 2000, and 2010, maybe up to 1990 and maybe even up to 2000, you could get reasonably good demographic data. But after that, it was, you had the invasion by the US, you had the Arab Spring. And so we did do a few other countries. You might say, well, why did you do Libya then? And part of the answer for that is that Libya is a relatively, like Somalia and Libya are two countries where the data are not that great, but they're very small populations, relatively speaking, sparsely settled countries. And so we felt somewhat more confidence in modeling those countries than compared to doing these really large, demographically significant countries in the Middle East.
Great, thanks. We got a question in the chat from Samuel. Sam, I invite you to unmute if you're in a position to do so. Otherwise, Alex, you can take a look at it and feel free to respond to it.
Yeah, I'm looking at it. If Samuel wants to say anything more, I'm happy to wait. Oh, no worries, Samuel. Okay,
yeah, no
so when oil becomes less valuable, I'll just read it out loud, so it'll help me. Thanks for your presentation. I'm curious to know how much we can anticipate how different parts of socioeconomic systems will interact to strengthen or degrade each other, and what effect that will have on migration. E.g., a lot of people currently move to oil-rich countries. Interesting, yes. So when oil becomes less valuable, this migration will presumably slow. Can or how can socioeconomic factors be reliably included in models? Well, that, part of what I wanted to, if I'd gone through the entire presentation on how the model works, we do include socioeconomic drivers in the model. And now, we don't really look to that said, we don't really look at international migration. The model, the way we've developed it is country by country. That was partly to sidestep some of the really thorny issues of whether there would be projected migration out of one country into another, but partly because mostly because the model itself operates on national assumptions about how population distribution will shift within the countries. And so what I would say is that when you start doing modeling of migration between countries, you absolutely have to look at the economic levels of prosperity and project those forward. And it will be very interesting to see what happens to some of the Gulf countries, as their temperatures, become higher and higher, and the degree to which they're able to mitigate that or adapt to that through space conditioning or other things is, I think, pretty strong, but it could become, tested to some degree. What a lot of the Gulf countries are doing, though, is, realizing that they need to move from fossil fuel based to sort of more knowledge based economies. So I visited United Arab Emirates a couple times, and they're really banking on being able to kind of transition from being heavily dependent on natural resources and oil, particularly, to being much more about higher education and well-educated workforce. We'll see if that scenario succeeds, but that's sort of what they're betting on. But the question is great, because there's no doubt that many regions of the world and countries have suffered boom and bust cycles as a result of fossil fuels. So history could repeat itself in some parts of the world, and even in the U.S., like Dakota gas fields. I imagine if those suddenly become exhausted, that we'll see more people moving out of that region.
Great, thanks, Alex. Yes, good. Other questions, reactions to what we got here? Nathan, yes, please go ahead.
Yeah, thank you so much, Alex. I really do appreciate this. And one thing, and maybe this isn't quite a fully formed question, more of just something I'm trying to wrestle with in my head throughout this, is kind of the difference between climate drivers and those economic drivers. So, for example, if like some of the information you had on China, I know at least there's a good push for people moving out of the countryside into larger cities for kind of economic development and economic reasons. And so I guess I'm just trying to kind of understand the balance between those economic factors and when the kind of climate really comes in and plays a role in that. And maybe, yeah, so.
Yeah, that's a great question. So the model that we use actually takes as a starting point a world in which only socioeconomic and particularly economic drivers affect population distribution. So what we actually do is just project forward two different population distributions, one of which is purely driven by the economic and social factors you just described. And so that kind of would show a lot of population growth in this coastal band along China. And then the other model takes into account not just the economic factors, it does include those, but also climate impacts, again, on water availability and crop production. For countries like China, I'm guessing that, I'm guessing here that the climate factors are actually not going to be very significant. And so one of the misleading elements of these maps of hotspots is that they imply massive movement, but actually it's not necessarily going to be that great. It'll be marginally slightly more than it would have been under a no climate impacts or socioeconomic scenario. And so it's what you're seeing here is probably due to the model inputs that we're using, showing, let's say, increased water availability in this region. I haven't actually scrutinized China's results very much yet. So I'm kind of doing this a little on the fly because we had something like 100 and something 20 countries that we modeled globally. So I haven't actually looked at every single one. I spent a lot more time scrutinizing the data in Africa because that's of particular interest to some of the donors we work with. But what you're seeing is movement out of the western portion of China, out of the southern portions of China. In this area, Gansu province, I've actually visited, and there's a lot of kind of, it's becoming increasingly dry in some of these regions. This area too, though, in north of China, Beijing is also projected to be somewhat drier, I think, in many models. So I'd have to look at that closer. I've talked too long, but that's sort of my nutshell synopsis of what we do with the model and how that may influence some of these changes.
Yeah, great question, Nathan. Thanks, Alex. Other reactions? Well, I just want to thank you again, Alex, for presenting today. It was a great conversation. I'm going to put in the chat window the registration link for next week or next month's installment on Monday, June 6th. So encourage everyone to take a look at that. We'll be hearing from Fern Hickey and Dr. Miyuku Hinu, who will draw on examples from 4 different U.S. cities to shed light on some of the challenges and opportunities that accompany climate-driven in-migration, measures that these communities have taken to respond to or prepare for it, and the policy changes that may be necessary to better support climate migrants and the communities poised to receive them. So some really great content here, Alex, and I just want to thank you personally. Thanks, Skylar, and the whole GCS Color of Climate network. It's been a great conversation, and we look forward to seeing you at next month's installment. Bye-bye.